going to finish problem 10. This is where the video left off. So what we ended up doing is we took the 3 and multiplied it to the top, and we took the 4 and multiplied it to the bottom, and we're solving with elimination. So now that we have the 12s, now we check, is one of them positive and one of them negative, and actually we already have that. One is positive and one is negative, so we're going to add the equations together. 18 and 20 makes 38x, 0y, so I don't write that at all. And here, 8 and 8, 16, 76, so negative 76. And if we divide out 38 on both sides, x is negative 2. So then to finish this out, we're going to substitute x is negative 2 back into one of the equations, and it doesn't matter which one you use. So I'm going to use the bottom. 5x, but we know x is negative 2, so 5 times negative 2 plus 3y is negative 7. And here we get negative 10 plus 3y is negative 7, add 10. Negative 3y equals 3. Divide negative 3 and y is negative 1. So our final answer, those points, the point that the graph would meet at is negative 2, 1. That's the solution they have in common. Solve the system with substitution. If you notice here, there is no x or y alone. So that's the first thing you have to do. And do you see this x? That x is almost by itself. So to get that x by itself, we would add 3y to both sides. And x is all alone now, equal to 14 plus 3y. Those are not like terms, so we leave them separate. We're going to take what x is equal to, and we're going to plug it in for x on the other equation we haven't used yet. So we'll have 12. Going to plug in 14 plus 3y. That's where the x goes. We put all of that in place of x minus 8 equals 4y. Distribute 12. I had to get more room, so now if I distribute 12, I get 168 plus 36y minus 8 equals 4y. And from here, I could combine these like terms right here. 168 minus 8 is 160 plus 36y equals 4y. I want to get my y's on the same side of the street, so it would be better to leave 160 alone and move the 36y over so that 160 is all by itself and you have negative 32y on the other side. If you divide out negative 32, y is going to be negative 5. Then we plug it back in, and it doesn't matter again where you plug it back in. So let's go with the top. X minus 3, plug in negative 5 equals 14. A negative 3 times negative 5 is positive 15. And if you minus 15 over both sides, you get x is negative 1. So that's the solution point they have in common, negative 1, negative 5. Skipped one. Okay, 12. Is the point 9, negative 2 a solution to y is greater than negative x plus 7? Could we graph this and see if that point is in the shaded region? Yes, but it is actually easier to just plug in x, plug in y. So y is greater than negative x, or negative 1x plus 7. I'm going to put in place of y, negative 2, in place of x, 9. If I multiply this out, that's negative 9 plus 7. And over on this side, I got negative 2. Is negative 2 greater than negative 2? No, it is not. It is equal. And we don't have the equal to line, so no, that is not a solution. Which of the systems of equations is graphed? Well, if you look at the point where they meet, it's 1, comma 1, x, y. That means that point, 1, 1, x, y, has to work in both of the equations for the equations to match the graph. If you look right here, if we put a 1 in for x and a 1 in for y, what's 1 plus 1? We get 2. That does not equal 4. So A is out. The next one, if we put 1 and 1, 1 plus 1 is 2. So now I check it with the bottom one. Negative 3 times 1 is negative 3. Plus 1 more is negative 2. That did not get me a negative 1. Therefore, B is out. Let's try C. Put a 1 and a 1. Negative 1 times 1 is negative 1. Plus 2 more really is 1. So the top equation works. If I put a 1 and a 1, 3 times 1 is 3. Take away 2 more. That really is 1. So the answer, it looks like it must be C, because that point 1, 1 worked in both equations. If you try it on the last one, 2 times 1 is 2, minus 1 more really is 1, but 3 halves times 1 on the bottom equation is still 3 halves, and that's not 1. So the final answer here is C, because those equations work for the graph. If you plug in the solution, it works in both. Kim's class had a bake sale. They sold cinnamon rolls for $3 each and cupcakes for $2. If the class sold 95 treats total and they made $240, we want to know how many of each treat did they sell. So again, I'm going to set up the money equation just like I would do any other time. So we got money, money, money. $3 each for the cinnamon rolls. I'm going to use C for cinnamon rolls. And then $2 each for cupcakes. I'm going to use K for cupcakes. So what the C represents, it's the number of cinnamon rolls sold. Therefore, K is number of cupcakes sold. And if you look here, we need another equation equal to total treats sold. And if we do C, don't put money anymore. We don't want money. Plus K, we got cupcakes or cinnamon rolls sold plus cupcakes sold equals total treats sold. And from here, we got a 1 and a 1. So we could use elimination. We could either times the top by 1 and switch 1 and 3 or switch 1 and 2. I'm going to times the top by 1 and I'm going to times the bottom by 2. So we have 3C plus 2K equals 240 and 2C plus 2K equals 190. And now from here we got 2's, but I need one of those 2's to be negative. I'm going to change the signs on the bottom equation to do that. Now I can add these together. 3 plus negative 2 is 1C. 2 and negative 2 make 0. And 240 and negative 190 make 50. So C is equal to 50, or cinnamon rolls is 50 sold. And now if there was there was 95 total sold of both, how much more do I need to sell of the cupcakes? Well, I would need to sell 45 more cupcakes to get that 95 total. The yellow cab is $2. And actually on this, you can actually see the colors, so you don't need to write that in. What is the minimum number of miles as a whole number that a customer would travel in order for the blue car to be less expensive? Notice up until I get to the point where they meet, or where they're equal in cost, the blue car is more expensive until this point right here. So if I go one whole number out from there, notice where they meet is at the number 3. And if I go one whole number out from there, it would be 4. So 4 miles, do you see that's where the blue would be less or beneath the yellow, less in cost. So that would be at 4 miles looking at the graph. If the system is to be solved by elimination of x, the first equation is multiplied by 2, then what number should the second equation be multiplied? So it said the first equation, that would be the top equation, says that's multiplied by a 2. Notice they brought the 2 up, and so if we're bringing 2 up, that means we would need to bring 5 down. So the answer here would just be 5. You would have to multiply the second equation by 5. Given the equation negative 4x plus 5y equals 40, which ordered pair is the y-intercept? Well, a y-intercept, if you graph these points 0, 8, 1, 2, 3, 4, 5, 6, 7, 8, 0, 8 is on the y-axis. 8, 0 though, 1, 2, 3, 4, 5, 6, 7, 8, is not. I can cross this point out right away because that's not on the y-axis. Additionally, point C, if I do negative 10, it's somewhere over here, and that is on the x-axis also. So point C is out. And now if we just plug these numbers in and see which one is the solution, that'll tell us our answer. So I'm going to see if this works. If I plug it in, I can type it in the calculator here. Well, this is 0. 5 times 8 really is 40. So it looks like A works. Let's just try D to make sure. So I'm going to put in 0 plus 5 times negative 10 and 40. This is 0, this is negative 50, and negative 50 does not equal 40, so D is out. Which of the following equations is equivalent? Equivalent means equal, and in this case, do you see that the y, what they're doing is they're getting y all by itself. So we're solving for y here. So to solve for y, we need to get rid of the 4 and the negative 8x. First thing we do is get a 0. So how do we get 0 here? We add 8x. Add 8x. 4y equals negative 20 plus 8x. And from here to get rid of 4, we'll divide everything out by 4. So y equals negative 20 divided 4 is negative 5. 8 divided 4 is 2. So we look at the answers that have a positive 2x. Well, it's not this one. Positive 2x. Okay, so it's either A or C. And then we need a negative 5 or subtract 5. So this answer is C. Write the inequality of the graph. If we want to write an inequality, we want it of the form y and mx plus b. We can first put the inequality sign. If you notice, that is a solid line. So we know we have the equal to, and that line is above or shaded above the line, so that is going to be greater. And then the y-intercept, or the b number, is going to be a 4. Positive 4, that's where it hits the y-axis. And from here, if I go down, down, down from the line, the first point where it actually hits through the center of the grid is here. So if you go down how many over how many, that would be 3 over 1. Well, I could put down